Welcome protein coders, let's build some coding muscles. Today we're gonna see minimum spanning tree, but first let's see what is a spanning tree. It is a subset of edges of graph that forms a tree where every node of the graph is a part of a tree. I know you don't understand it, let's see. What's a tree? If it has n nodes, then it should have n minus 1 edges. And it should have no cycles and all nodes should be connected. Okay, let's see with the diagram. Let's look into the first diagram. It's a graph, okay? So to make a spanning tree, what we have to do? We will remove the unnecessary edges, okay, to remove the cycles. Now it's a spanning tree, right? It doesn't have any cycles and there are n minus 1 edges for n nodes. If we see for the second example, like this, we can also make a spanning tree like this also, okay? So this is a spanning tree. Now let's see what is a minimum spanning tree. So in a weighted graph, that spanning tree, because a graph can have multiple spanning trees, right? So that spanning tree which has total edge weights as minimum, okay, that spanning tree we will call as the minimum spanning tree of that graph. Okay, so let's make spanning trees for this graph. Let's make them spanning tree by erasing the extra edges. Okay, third one also and the fourth one also. Now let's count the total edge weights. It is 8, 7, 7 and 5. So the last one will be the MST or the minimum spanning tree of this graph. And for finding MST of a graph, we use an algorithm called as Prim's algorithm, which we're going to learn today. Okay. Now let's see what Prim's algo says. So in this graph, let's choose a node number 0 and we have 3 edges going out, right? 4, 8 and 7. So we'll choose the minimum one, which is the 4. Then we have 1, 8 and 7. Again we will choose the minimum edge, right? Then we have 11, 8 and 7. Then this time we will choose the 7 edge, okay, because it is the minimum. So we'll connect 0 and 2. Now again we have 2, right? 8, 9 and 11. Which edge to choose? The minimum one. We will move to 5. So similarly, in every iteration, we will choose the minimum edge available, okay, and move to that node and mark it as part of our MST. So if I draw my MST here in this graph, it will be like this, okay. So what points we got from get here? Choose a node, okay, and then pick node with the shortest edge or distance or minimum edge, okay, and mark it as part of the MST. Let's see it in more detail, okay, what we have done here. And for the picking the shortest distance, we will use a min-heap, okay. Let's see. Again, let's have the following graph and we have our MST vector, minimum spanning tree vector. Let's start from 0 and mark it as a part of our MST. Then we have 3 edges, 4, 8 and 7. We will choose the minimum one and we'll move to 1. Okay, and we'll mark the 1 as the part of our MST. Now we have 3 edges, 1, 8 and 2. Oh sorry, 1, 8 and 7, right? So 1 will be the minimum one. So we'll move from 1 to 3 and mark node number 3 as part of MST. Now we have 11, 9, 8 and 7. Right, then we will move to the node number 2 with edge 7. Then from 2 we will move 5, right, we will mark them in MST. Again we will choose the shortest edge, right, and mark 4 in our MST. Right, from 4 we will move to 7 and from 7 we will move to the shortest one, which one is the edge number 4, right? We will move to number 6, mark it as part of MST, and finally 5 to 8. Okay, so this is the Prim's algorithm. That's it. In priority queue, we will take the first element as weight and second will be the node. Okay, let's see in the code how we're gonna implement this. It will be similar to BFS, but slightly modifications, okay, because we are checking the neighbors and choosing the shortest edge neighbor, right? Let's see in the code. Let's have our spanning tree function. Okay, first let's create a vector boolean in MST. okay, to mark the nodes present in MST or not. Initialize with false, and we will initialize our priority queue. Here PII means pair of integer comma integer, okay. And one more thing, in this question we have to return the sum of the edge weights in our MST, okay, the total weight of the MST. So let's do first thing first. Let's push the edge weight 0 and node number 0 into the priority queue and initialize total weight as 0. Now let's start our traversal while our priority queue is not empty. Okay, auto it pq.top, pq.pop will pop the first element. Then we will get the weight and the node. So first element is weight, second is node, right, in our priority queue. Now we will check if the node is already present in the MST, then we will continue, because we don't want to form the cycles, right? Else we will mark this node as the part of MST and we will increase the weight. Total weight is equals to total weight plus weight. Now let's travel the neighbors of the node, okay, available neighbors. So using adjacency list, we will get the neighboring node and the neighboring node edge weight. Okay, let's call it WT T1. Then we will check if the neighboring node is not the part of MST, we will simply push it into the queue or priority queue. The neighboring node weight, comma, neighboring node. And that's it, guys. And at the end, we will simply return the total weight. So that's it. That's it, our Prim's algorithm. Let's revise what we have studied today. First, we saw about the spanning trees, right? Spanning trees in the graph in which there is no cycle, all nodes are connected, and there should be n-1 edges for n nodes. Okay. Then we saw the minimum spanning tree, in which the graph should be weighted, and that spanning tree which has the minimum total weight, edge weight, will be called as MST. For this, we use Prim's algorithm, right, in which we choose a node, pick the node with the shortest distance and mark it as part of MST. And for picking the shortest distance node, we'll use the priority queue or Min-Heap. Then we saw the code for this, which we have a vector in MST, priority queue, right? What we did was, if the node is already part of MST, then we'll continue, else we'll mark it true, count the edge weight and traverse for the neighboring node. If the neighboring node is not part of MST, then we will push it into the priority queue. So that's it from my side, guys. Thank you for listening. If you have any queries, please mention them into the comment box. You will find the problem and the solution link into the description box. If you don't understand, don't like, don't subscribe. But if you do, please show some support. Keep smiling, keep practicing. Thank you.